Excel sheet column title marks an interesting landmark in my LeetCode journey. This LeetCode problem has a solution that is trivial to understand but surprisingly difficult to conceive, at least the solutions that I've seen so far. Such a solution, however, is not my solution. I have looked for the solutions in the Discuss page right here, Discuss tab, of many different problem solvers and have yet to find one quite like mine. Due to the rarity of my solution, I feel compelled to explain its birth. This is a greedy algorithm where we place emphasis on building our solution one by one, maximizing or getting an optimal local solution and using that to generate the correct global solution. Our problem statement is fairly simple. We're given an input column number, right? Which is an integer, and we need to return a column title, okay? If you guys have done Excel, you see it goes from A, B, C, D, E, all the way to Z, and then it goes AA. If you look at the top where all the cells are, right, all the titles, you'll see that it goes in a very particular order. So we need to return that Excel sheet column title given a particular number, okay? So we need to be able to make the conversion. And so how might we reason with a problem like this? For me, the first step was understanding the relationship between numbers and their corresponding column titles. We know that the number 1 refers to column A, and number 2 refers to column B, number 3 refers to column C, and so on. We also know that there are 26 letters in the alphabet, hence why, given our previous axiom, it's clear that 26 will refer to column Z, okay? We can confidently say that any number between 1 and 26 refers to only a single character. But what happens when our column number is greater than 26? Okay? Let's think about this for a second, all right? At first, we have a limit from 1 to 26, right? If our column number falls in between this range, we're good to go. You know, we're absolutely solid. We can just return that column number, the column title that the column number refers to. And the way that you can do that, I mean, we could take 64 plus any one of these numbers to get the ASCII value of the character that we want to return. For example, like if we do 64 plus 1, then we get 65. Well, we can convert 65 to A using a special string function. I think it's from character code, and we pass in 65, we're going to get A in return, and we can just return that, okay? But again, what if our number is greater, what if our column number is greater than 26? As we can see, this is literally going to the maximum integer size, 2.147 bil, right? So this can be really big, right? Where we're talking like, well, a billion. It could be really big. So if we examine a number, so if we pass in like 27, or if the function gets passed in a number of 27, we know that 27 exists in a different kind of range. We just don't know exactly what those boundaries are yet. And from the example, we know that 27 refers to AA, right? Well, do you agree that any number greater than or equal to 27 is bound to have at least 2 characters in it? Okay. And do you agree that if we pick A to be the first character, we can make 26 combinations out of it? We can go AA, AB, AC, AD, for every letter in the alphabet, which is 26 letters. So, if we are not at the final letter, we know that any letter before it refers to the potential number of combinations you can make. So we end up getting something like 26 times n plus m, maybe. We can do something like that, where n refers to exactly which character we're referring to. For example, so we get something like BABB. Well, we know B is 2. We know 52 combinations can be made. And you're like, wait, what? 52? Well, think about it. before we get to BA, like think about it like in the Excel sheet way. It's gonna go all the way from AD or from AA to AZ before it touches BA. So we have to include every previous 26 combination before we get to B. Hence 26 times 2, where we have 22 or 26 plus 26. The first 26 referring to all the previous combinations. The second 26 referring to what can be the possible combinations for the letter B, right? Plus M, which is this last character, whatever it is. So we want to find out what's BA. We can do 26 times 2 plus 1, because A refers to 1, B refers to 2. We use that to multiply by 26 the potential combinations, right? And we see how this pattern works. So for ZZ, if we get all the way to ZZ, what we end up having is 26 times 26 plus 26, right? Because if we had AA as 26 times 1, we have 26 potential combinations. If we're looking at BA, we know that B has 52 potential combinations. If we look at CA, we know that it has 52 plus 26 combinations. If we look at DA, we know it has that result plus 26. So we have 52 plus 52, so we have 108 or 104 combinations. So it just keeps going like that. It keeps building and building and building, because we have to include every potential combination beforehand and then the combination from that character itself, which is 26, right? So then this would lead us to a pretty big value. I think the value would be, let's see, for ZZ, what's 26 multiplied by 26? Maybe I've written it down somewhere. So I think the answer is 702. Okay, so we know this range is from 27 to 702 technically, but that's not what we want to do. The way I'm building this out is that I want to first understand how many letters are in our output. So if someone gives us a number like maybe they give us 2,600, I want to be able to know that this is going to have 3 letters in the output, right? And I want to have an array that specifies the range, some specific range for each letter. So for the last letter, 1 to 26, for the penultimate letter, it's actually 27 to 676. And so you say, oh, why 676? Well, actually, we're just going to take 26, multiply it by 26, right? And we know that the max from here, so if this was Z, for example, so let's do this real quick. Our previous example, if it was Z, if we had ZZ, that would just be 676, right? And 26, which is going to get us 702, the number that we had before. So I want to essentially know how many letters are going to be in the output. And then in a greedy way, we are going to use these ranges to get the output that we want. And this would just be 677 and then whatever that is times 26. I don't know what that is. So that's how we're going to do it. Let's start with writing the code a little bit and see if it begins to make some sense, because it's actually a very interesting solution. My brain was just thinking on a weird, very, very weird. So yeah, the first thing we're going to do is we need to understand how many characters, how many letters are going to be in the output, okay? So let's specify a bottom limit, top limit of 26. I is going to specify for us how many characters are going to be in the output, right? So while we are not in the range, so how do we know if we're in the range? We know if we're in the range if the passed in column number is between the bottom limit in the top limit. But if that's not the case, then we're not in the range. And what we do is increment I, change our bottom limit, change our top limit. Now this is different than the limits that are going to be inside of our array. This is very different. This is just to specify, for example, if we pass in 2600, I just need to see where, I need to see how many letters it's going to take to get to this value, right? And so I can do that by seeing in what range this exists in, including every single potential letter. So we're not going up to 676, we're going up to 702, and we're not going up to this, we're going up to this plus what came before it. So it can get pretty big, right? So yeah, so like, I guess a more clear example is if someone passes in 702, we know that should be ZZ, right? So ignore this for now. We just need to see, okay, well, the original range is from 1 to 26. The next range is going to be from 27 to 26 multiplied by 26 plus 26 to include the characters in the first letter, right? And that'll end up being 702. Now, since it's in 702, right, less than or equal to, greater than or less than or equal to, greater than or equal to, we know it's in that range, then we know I is going to equal 2, or actually, technically it's going to equal 1. So let's take a look at I really quick for all the test cases. It should be 0, 1, 1. 0, 1, 1. And we know that if I is equal to 0, then we only have one letter. That means we never had to change our boundaries. We never had to do that. So we can just return a string from character code 64 plus column number. Because remember, 64 plus whatever number we get will give us our ASCII value. And from that code, we can actually get the string. So for the first case, it'll work. For one, it should work, right? We actually get that A. For the other ones, obviously, we're not returning anything. Okay, so that's our trivial case. We just need to figure out, okay, we need to have, so our I is 1, and we know that means our output should have 2 elements, okay? What we're actually going to do here is a little bit of wizardry, I guess you could say. We're going to say, okay, our results, really just our result array. We're going to create an array using I. And intuitively, you would think, okay, no, you should use I plus 1. But actually, if we had a number like 2600, what we're going to do is we're going to find the largest number between this range, the largest number, so let me make sure you guys can actually see what's going on here. Let's get rid of this for a second. What is this number here? It's 17. So we need to find the largest number in this range that is less than the column number, and within our limits, and takes into account that there are still letters left. So we need to maximize the value we can get here, while also ensuring that we're keeping space for the last value, and we're within our limits. And once we find that number, we can use that to subtract our column number, right? So for something like 2600, we can say, oh, okay, well, we can put, this is the max number that we can decrease from 2600, given our constraints. And then, or sorry, let's do it for a different example. Let's do it for, I'm looking at my notes here. Let's do it for this right here, because it's very intuitive. So we subtract this, the max number that again follows our very specific boundaries, our rules, and we subtract it from the total, and the total becomes 27. And then we want to find the max number in this range that I can subtract 25. I'm given 1. All I have to do is at the end just append 1 using an array method like push. And then I'll end up having the desired output. Yeah, you shouldn't, you know, if it works the way that, if it works as intended, this last number is going to just be within this range of 1 to 26. So you don't have to do any extra arithmetic. You just append that number at the end. So you see where I'm going with this. So, and then we want to actually divide this by its range. Divide this by its range and leave that to get something like 3, 1, 1. Which then we know 3 is C, 1 is A, 1 is A. We join them together. CAA is our output. That's the goal, okay? That is the goal. So we have our result. We're going to use K to calculate dead space. And I'll show you guys why that matters. I just called it dead space. I don't know if that's even a proper way to go about it. But essentially I'm going to iterate through, I'm going to be creating, so I created my result array and I'm going to be iterating through it-ish, placing in each index the result that I want to place in there. So we're going to use the same bottom limit, except now it's going to be doing something a little bit different. Top limit as well. Nice to have you. 26. I'm going to create a variable called start value, actually. Yeah, let's do that. Start value equals bottom limit minus 1. So what we're doing here is, this is actually our range, right? We know that the high end of the range is just multiples of 26, or not multiples of 26, 26 raised to different powers. So, you know, you starting at 1. Okay, 26 raised to the first power is 26. That's our maximum. Okay, 26 raised to the second power is 676. 26 raised to the third power is whatever that number was, 17,500, whatever that was. And start value is where we're going to start from. So let me show you guys really quick. Now, if K is equal to 0, then the dead space that we account for is only 1. And so why this is important is because, again, if I'm looking at, you know, 2028, 26, and 1 from 2055, I want to find, again, the biggest number while acknowledging that there is a minimum of 27 as a value that we need to have remaining. Like, this can't exceed a particular value and then leave no space for the next element, right? Because we want to end up plugging in the maximum values in each index, right? And if we put something like say for instance we put this here. Okay, and then now the only thing we have left over is 0, and then we have 0. We don't want to do that, right? We want to get the max value that still allows for, because we know if we have a 3-letter string, we know that we need 3 letters. It's not like we can leave one empty. Like 0 is not going to do anything for us. Like there's no situation where we can leave one empty and it'll still be a correct solution. So we need to account for that dead space and make sure. So here we're gonna. And maybe I'll do like let total equal column number. Yeah, it should be fine. Right. So we're going to take whatever our starting value is. We're going to keep multiplying it by an increasing integer. So by 1, and then by 2, and then by 3, and then by 4, and then by 5, to see if we can get the maximum value that also simultaneously accounts for dead space and is within our boundary. It's a very interesting solution. Say, all right, so you access J. I don't even know if I need math.max. It's just like, I can imagine if this never runs and our multiplier is 1, and I don't want to take 0 and multiply by start value, that's going to zero out everything. So if it is 0, pick the maximum between 0 and 1, which is 1. That was just a sanity check. There are a couple sanity checks in here that I haven't even taken off. You know, some of it might be like useless, but like if k equals 0, I don't know if k will ever equal 0, if I'm being honest. It might. It might. I'm not sure. And then now let's look at our results variable. So our result, oh wait, hold on, we messed up somewhere. Actually, no, we didn't. No, we didn't. We just don't have an intricate enough input. Let's give it 2600. Yeah, there we go. And let's give it the one that we were talking about, 2055. You see these two numbers? Right. So then, what we do from this point on is, and now just to be extra clear, you know, in this case, our I is 2, so our bottom limit is 2 minus 0, so it's 26 to the second power, which is 676, which is actually 677, which is what we specified before, to 26 to the third power, which is whatever that value is, and then the next iteration, j increases, so then we take 2 minus 1, because j is now 1, which is 1, so 26 to the first power plus 1 specifies our bottom, which is 27. Then we take 26 to the power of 2, which is 676. So you guys see how this is working, and then we increment j again. When we increment j that last time, j becomes 2, so we break out of the loop, right? You guys see how I'm working that. I wasn't very clear on how that worked, but it was something I mentioned before. I just wasn't really touching on it when I was creating the loop. So now we're going to start actually putting the characters where they should be. All right. So expecting cuz and ka. Now, while we do that, let's spectate how much is left in total. Remember, total should be a value from 1 to 26. Here, total is 1, which means when we plug in that last number, we're going to get that A. And here, it's 26, which means we're going to get the Z. And then what we return is the result join, which essentially turns our array into a string. And bam, there's my overcomplicated solution to this problem. There you go. In terms of space, it's actually dog water. You know, which is interesting. I mean, we have an array. I never saw an array as, I mean, you know, an array is, see this, yeah, this changes all the time. One time it was 57 milliseconds. If we run it again, it's going to change. An array consumes O of n space. It's not clear to me that this is exactly an O of n thing. It actually is. I feel like it's log n. It's like log 64n. Because if you have like 2600, then your array doesn't actually get that big. Your array is 3 elements, for Christ's sake. So I think, you know, I think log something. It's really not a lot, but yeah. That's my overcomplicated solution to this problem.